some of you are having trouble doing active chemistry's dimensional analysis, so I want to walk through how to look at these questions. So first, we're going to take note of some things that are features that are supposed to guide you, and then we'll walk through a couple of examples. So notice that these rectangles here have different colors. The first one is a dark color, dark blue, or it may look black to you, and the second one is red. And then if we look over here, all of the numbers are blue and all of the words or units are red. And so that indicates to us that when we're placing things in those boxes, they should be blue in the blue boxes, or numbers in the blue boxes, and units in the red boxes. The next thing that we want to look at is that each of the numbers and in the problem have with it both the color of the number and a unit with it. So make sure that when you are dragging your numbers, and you can drag it either from the bottom part or from the question itself, make sure that you are putting the correct unit with it. So if you put 0.5 in the boxes, you're going to drag the liters over there as well. And then also pay attention to what the question is asking for. So we want our final answer to have these units. Now, preferably it will say moles of glucose. Sometimes, like this M here, doesn't have what chemical it is. So if it just ends up being moles, that's okay as well. All right, so now for putting things into the boxes. We want to pay attention to the difference between what is an amount and what is a ratio. So liters tells us how much is there of this particular solution, and capital M is molarity, and that's moles per liter. It has two different units that are part of it. That is a ratio, or a factor that we can multiply by. So every time we start the dimensional analysis, the first thing is not going to have a fraction. We want to start with an amount. We want to start with something that is just how much is there and only has one unit. So in this case, liters, or volume, is our amount. So all right, so what do we do about this empty box here? If we have dragged over a unit that has become 2 units, that should be a 1. So it's always a good guess that that's going to be a 1. Now, if you end up with a 1 on top and bottom, you might want to think a little bit more carefully about it. So molarity means how many moles per liter. So that means per 1 liter. And that's why we end up with that on the bottom. And then at this point, you put your answer. Your answer should have the only remaining units, so moles of glucose. So I'm going to take this from here, moles of glucose, and notice how it changed from the word glucose on the bottom to the chemical formula. So it's showing me what is left over. And then I'm also going to do the math and then put that number there as well. And if I remember correctly, it should look something like that. Okay, so the other thing that we can do, let me drag these out of here and start over, is use dimensional analysis to answer this. So let's say I couldn't remember the formula. but I know where I am and where I'm going. So I have the unit of liters. So liters needs to go on the bottom to cancel. And I know I want to go to moles. So I'm going to go ahead and put moles of glucose on top. Then I'm going to look back at my question and see I have 0.4 with this capital M. So hopefully we remember that that capital M is moles per liter. So we know that that should go in that spot. If not, then you're going to want to check through your notes and see, okay, what has units of moles per liter? Because we want something with a ratio. A factor is a ratio. So then I might ask myself, well, where am I going to put this 0.4? Does it go on the top or on the bottom? It is going to go wherever the first unit goes. So when I say molarity is moles per liter, I'm saying moles first. So it's going to go in the same spot that moles goes. All right. And again, we're going to put the 1 on the bottom. Our units have all canceled and we're left with moles of glucose. And I think that works out to this. And hopefully this will check me. And yes, I'm correct there. Okay, so that was just kind of a one-step problem. Now let's look at something that is a little bit more complicated. So we're trying to end up in milliliters, and we know that molarity is always in liters, so that's going to be an extra factor in there. And we're not starting with moles. Instead, we have grams and we have a concentration. So between the two of these, which tells us how much is there? The 30.2 grams, is that the amount of sodium chloride, or is the 0.2 molar the amount of sodium chloride? So remember that the capital M is a ratio, not an amount. So we're going to go with the grams of sodium chloride. And one way we can tell is there is only one unit there. Okay, just the grams. Now, we ultimately want to get to milliliters, but we don't really have a factor that goes directly from grams to milliliters. So we can think about what are the steps we need to follow. First, we need to find moles. So we want grams per mole. And in order to find moles, we take mass divided by molar mass. So you could put this here and then put in the molar mass of sodium chloride, which if you calculated should be the 58.44. Okay, so that's one way you can think about it. The other way you can think about it, if you don't remember what the calculation you need to do is, we know we need to get rid of this grams. So rather than taking the factor here at the bottom that has grams and moles, I can put grams on the bottom and then think about, well, does sodium chloride have a constant volume? I can't go directly to milliliters, and somehow I need to be using this other number that's in here. So instead of going from grams to milliliters, I'm going to go to moles. That's something I can calculate. So I drag this up here. Then I think, okay, what has units of either grams per mole or moles per gram? So grams per mole is the unit of our molar mass. So I calculate 58.44 and I think, okay, where is that going to go? Well, we say grams per mole is the units. So wherever grams is, that's where the 58.44 is going to go. Okay. Or you can check your notes and see that in order to find moles, we need to take the mass divided by the molar weight. All right. This has gotten us to moles, but we want milliliters, so we're going to add another factor. So now I want to get rid of moles of sodium chloride, and I want to go to a volume. So this molarity takes into account moles per liter. Okay, so I can put liter up here, or I can say, you know what? What if I just put molarity here? Now, what if I put it in the wrong spot? What if I put molarity on the top spot? Notice that my moles don't cancel each other out. They're not crossed out. So if I'm seeing two of the same units, both on top or both on bottom, I might want to think about swapping places with them. So I'm going to try this again with it on the bottom, and notice my moles cancel, leaving me only with liters to deal with. Okay, so this came from this M here, which means this unit needs to go with it. And this 0.2 is going to go where the first unit, it's moles per liter, so it's going to go wherever moles goes. All right, and so that means I have 1 liter here. So one problem people have is leaving blank spots. If you're finding that it seems right, but you've got blank spots, try sticking in ones where the blank spots are. Now, finally, we need to get the appropriate units here, milliliters. So we're going to add another factor. And so we are going to put milliliters on top and liters on the bottom. I put the unit I want on top, milliliters, and I put liters on the bottom so it will cancel over here. Okay, so I can convert between liters and milliliters, and that's just a factor of 1,000. So then I have to ask myself, do I have 1,000 liters in 1 milliliter, or do I have 1,000 milliliters in 1 liter? And the answer is 1,000 milliliters in 1 liter. Then I put my 1 on the bottom, and I check to make sure all of my units are canceled, except for the one that the question asks for, milliliters. And then I think I'm ready to go. So I multiply through, and then I divide. Okay, so if I plug this in, I end up with about, I think it is 2,500 milliliters. And let me put my ml there and check my answer. There we go. So that is doing unit analysis. Hopefully this helps you in figuring out what to put where. And it really does help to start with the amount, the thing that only has 1 unit. It will either be grams or moles or some volume, milliliters or liters. Those are the only amounts that we will be working with.